Hi students, welcome to Madras Math Kernel. Today we are going to see again chapter 3, pair of linear equations in two variables, the concept and examples explanation for exercise 3.5. The subtopic in this exercise is cross multiplication. Right? It's a method used to solve given pair of linear equations. So here we are considering the problem. Considering the case, cost of 5 oranges and 3 apples is rupees 35 and the cost of 2 oranges and 4 apples is rupees 28. Let us find the cost of an orange and an apple. So your question is easily understood. One person is buying 5 oranges and 3 apples. It is the total sum is 35 rupees 35, and other person is buying 2 oranges and 4 apples. The sum of rupees is 28. We have to find out the cost of an orange and cost of an apple. So I am assuming the cost of orange as x, cost of apple as y. So I am putting whatever is given in the equation, whatever given in the question as an equation. So 5x plus 3y equal to 35, 2x plus 4y equal to 28, right? So what I have to do, I have to bring this 35 to this side and 28 to this side. I have to rewrite the equations. So after rewriting, I am getting 5x plus 3y minus 35 equal to 0, 2x plus 4y minus 28 equal to 0. Why this strictly you have to follow if you want to work out the problem in the cross multiplication method. So whenever you want to solve a problem using cross multiplication method, then you have to bring the entire x, y and constant to one side. The other side should be 0. This is the first step required and this is mandatory, right? So what I have to do, you have to, in the top you have to write x, y and 1. Then you have to start with the coefficients of y, right? Here the coefficients of y are 3, 4. So I have written 3, 4 here. X should be in the middle. You have to write in such a way how I have written in this sheet. So first 3 and 4 I have written. Then I should write minus 35 minus 28. And then like in a cyclic order you should write. So I have written y, I have written the constant, then I should go for x. So it should be like this, right? So this is 5 and this is 2 and then this is 3 and 4. Again you have to repeat 3 and 4. So you have to start with the coefficient of y, then you should move on to the constants, then you should write the x, then again you have to repeat your y. So first you have to write your y, then you should move on to constants, then you should write your x, and then the same numbers whatever you are writing here you should get repeated at the end, right? So for reference purpose I am writing it again. X, y, 1, right? 3, 4, minus 35, minus 28, and this is 5, this is 2, this is 3 and 4. Okay. So for cross multiplication what you have to do, you have to write this x by, you leave the space empty, equal to y by, this is y by, equal to this 1 by. All the top numbers should come in the numerator. X by something, y by something, 1 by something. Okay. Then what I have to do, I have to multiply the numbers in this order. These two you are cross multiplying the numbers. You have to multiply 3 and minus 28. I have written 3 into minus 28. And then you have to multiply 4 into minus 35. Before writing these two numbers, I have to incorporate a minus here, right? So I am putting a minus 4 into minus 35. Similar procedure you have to follow for these numbers also. So 2 into minus 35 and then you put a minus, then 5 into minus 28 equal to 1 divided by 5 into 4 minus 2 into 3. Okay. So this you should obtain, the entire thing you should obtain from the above values, right? So after that it is only simplification procedures. So x divided by, multiply these two, you will be getting minus 84 plus 140, minus into minus will become plus 140, y divided by minus 70 plus 140, 1 divided by 5 4s are 20, minus 3 2s are 6. Okay, and then again if you simplify, what you will get, x by 56 is equal to y by 70 equal to 1 by 17, 1 by 14. So I am assuming this part as subdivision 1, 2 and 3. So now I am comparing my 1 and 3, because here you have one unknown, here you have one unknown. If you compare your 1 and 2, you will end up in again unknowns only. You will not be able to find out the answers. So if you compare 1 and 3, you can see here you have a number, here you have some value, here you have some value. So obviously you can find out what is x. Right, first step you have to compare 1 and 3, you can find out x. Second step, you can compare your 2 and 3, then you can find out what is y. So on comparing your 1 and 3, I have written whatever it is in 1 and 3. So on cross multiplication, so what will happen, this 56 will go to the numerator. I didn't take this 14 to the numerator of this side. Why? Because I know they both will get cancelled. So 56 by 14 is equal to 4. So my x value is 4. The next step is comparing your 2 and 3. 2 and 3 part, y by 70 equal to 1 by 14. So y is equal to, take this 70 to the other side, 70 by 14, it is 5. So y equal to 3. So cost of an orange, it is rupees 4, and cost of an apple is rupees 5. So this is a general procedure for solving the given equations using cross multiplication method. So first we have to write down the general equations. a1x plus b1y plus c1 equal to 0, a2x plus b2y plus c2 equal to 0. Here your a1, b1, c1, a2, b2, c2 all are numbers. Okay, all are your integers. Okay, so you have three conditions for how this to find out the nature of the solutions for a given pair of linear equations, right? So you are given with two equations like this 1 and 2, right? a1 and a2 are the coefficients of x, b1 and b2 are the coefficients of y, c1 and c2 are the constant terms. So whenever you find a1 by a2, the ratio of a1 by a2 is not equal to the ratio of b1 by b2, what you can say? You can say the solution is unique solution. That is, you will be having only one x and y values, or only one pair of answers, right? Then coming to the second condition, when a1 by a2, that is when you find the ratio of coefficients of x, that is a1 by a2 is equal to b1 by b2 equal to c1 by c2. If everything is equal to one another, then you can say this, you have infinitely many solutions. Okay, you have infinite pair of solutions, infinite pair of x and y values for a given set of equations. And coming to the third condition or subdivision, a1 by a2, coefficient of x and coefficient of ratio of coefficient of y, if both are equal, and if you found this is not equal to the ratio of constants c1 by c2, then you can confirmly say there is no solution for the given set of equation. So how you remember? For first unique solution, it is enough if you consider the coefficients of x and y. And if all the ratios are equal, simply you can remember that you have many solutions, because this condition will be happening in few cases only. So this is a rare condition. So what you can say this, you have many solutions, and if at least this is equal, that is coefficients of x and y are equal, and then it is not equal to the constant terms, then you can say there is no solution. Okay, so coming to example 14, from a bus stand in Bangalore, if we buy 2 tickets to Malleshwaram and 3 tickets to Yeshwanthpur, the total cost is 46. But if we buy 3 tickets to Malleshwaram and 5 tickets to Yeshwanthpur, the total cost is rupees 74. find the fares from the bus stand to Malleshwaram and to Yeshwantpur. Okay, so here from a bus stand in Bangalore, if we buy 2 tickets, so 2 persons, 2 tickets and 3 to Malleshwaram, 3 to Yeshwantpur. So I am assuming the fare to Malleshwaram is x and to Yeshwantpur is y. So 2x plus 3y equal to 46, and then 3x plus 5y should be equal to 74. These are my equations. So whatever I said, I have written it here. I have assumed x and y as the fares. Then I ended up in writing the equations 2x plus 3y equal to 46. I brought this 46 to the other side. So this is my first equation and this is my second equation. And then I am writing x, y, 1. First I have to write down the coefficients of y. So I have written 3y. Then I should move on to constant. So minus 46 minus 74. And then you should write the coefficients of x, 2, 3 and then 3, 5. You have to repeat this y coefficients here. Okay, the common mistake what all the students will make is sometimes you will not be bringing this constant to the other side. Okay, so you will be writing the number 46 as just 46. Actually you are supposed to write it as minus 46. So since you are not bringing the number to the other side, the change of sign you will leave and you will be simply writing it as 46. You won't get the answer. Okay, this thing you have to correct while working out this cross multiplication method. So first what you should do, you should write your x, y, 1 and the numerator from here, right? And then you have to cross multiply these numbers by adding minus to the second part. So first 3 into minus 74 I have written here, then I am adding minus, then 5 into minus 46 I have written here. Same way 3 into minus 46, 1 minus and 2 into minus 74. 2 into 5 minus 3 into 3 is 9. So I have simplified, I have calculated the values here. It is x by 8, y by 10 and 1 by 1. So I am giving the name as 1, 2 and 3. So on comparing your 1 and 3, this is 1, this is 3. On comparing these two, I am getting x as 8. So fare to Malleshwaram is, I found it as 8. Comparing your 2 and 3, y by 10 is equal to 1 by 1. So y is equal to 10. Fare to Yeshwantpur, I found out as rupees 10. So coming to example 15. For which values of p does the pair of equations given below has unique solutions? So you are given with 2 equations and one unknown, one variable or one unknown value is there, that is p. You have to find out the value of p for which these 2 equations they will have unique solutions. This value you have to find out, right? So I have named it as equations 1 and 2. So what is the condition for your unique solution? You have to remember that for unique solution, ratio of coefficients of x and y should not be equal. Okay, so you should know how to write down a1, b1, a2, b2 from the given equations when compared with your general equations. So general equation, as I said, a1x plus b1y plus c1 equal to 0. So comparing this with first equation, you will be getting it as a1 as 4, b1 as p, a1 as 4, b1 as p, and your c1, if you want you can write it out. Since it is not necessary, I didn't write it here. So c1 is 8, and then similar way if you compare the second equation with the general equation, a2x plus b2y plus c2, I am getting a2 as 2, b2 as 2 and my c2 is also 2. Okay, so if I substitute this in the condition which is for unique solution, so for a1 I have substituted my 4, a2 is 2, b1 and b2 is p and 2. So 4 by 2, you just simply bring down this not equal to sign to the next step. 4 by 2 is not equal to p by 2. Then you cross multiply, you take this 2 to the other side. So p is not equal to 4 by 2, this is I am writing as it is, then taking this 2 to the other side, so it will come on the top, 4 by 2 into 2. 2 will get cancelled, so you'll be getting p is not equal to 4. So what you can infer, or what you can say for conclude from this, for all values of p except 4, because p should not be equal to 4, except for the given pair of linear equation, they will have a unique solution. So whenever you say p equal to 4, then you cannot conclude they have linear, they have unique solutions, right? Coming to example 16. For what values of k will the following pair of linear equations have infinitely many solutions? So now you have to, whenever you hear the word many solution, unique solutions, or no solution, you should bring the conditions in your mind. So what is the condition for infinitely many solutions? a1 by a2 equal to b1 by b2 equal to c1 by c2. So these are the equations given in the problem. Kx plus 3y minus of k minus 3 equal to 0, 12x plus ky minus k equal to 0. So first step, you have to check whether x and y variables, are they written in correct generalized format. So here x is having some coefficient, y is having some coefficient, and k and 3 you can consider them as a constant terms. Similarly here, some x, some y, some constant. So the equations are in generalized form. So I am writing what is a1, what is b1, what is c1. Comparing with your generalized equations, you can say this is my a1, this is 3 is my b1, a1 is k, b1 is 3, my c1 is minus of k minus 3, right? Similarly here, this is a2, this k is b2, and this minus k is c2. So I have written all those things here. Then I have written the condition for infinitely many solutions. Then I have simply substituted what is a1, what is b1, and what is a2, b2, c1, c2. So I am getting an equation like this, or setup like this. So what I have to do, a similar procedure what I followed there in the previous example problems. I am comparing. You have to see wherever you have unknowns. So simply I have taken here 1 and 2, and then I compared 2 and 3. Why? Because everywhere you have k, so no need to think for that x and y, only one unknown concepts here. So simply you compare 1 and 2, then 2 and 3. So I am comparing my 1 and 2. This is k by 12 equal to 3 by k. So what I am getting is k square is equal to 36. So my k is plus or minus 6. I am getting two values for k. Sometimes I may have plus 6, and sometimes I may have minus 6. Similarly, comparing my 2 and 3, 3 by k is equal to minus of k minus 3 by minus k. On cross multiplying, this minus will go off first because it is present in the numerator and denominator. Then if you cross multiply, you will get 3k, and then here it is k into k minus 3. So if you expand this side, it will remain as such. Here it's k square minus 3k, then this, you bring this 3k to the other side, so you will be getting k square minus 6k. So taking k common, k into k minus 6 equal to 0. So k equal to 0, or sometimes k equal to 6. So here I have another set of two values for k. So you have to compare these two. Simply you cannot write the answers here. You have to compare these values. Here 6 and minus 6, here 0 and 6. So the value for k you are going to conclude here should satisfy both the conditions. So I am taking k equal to 6 because it is present in both the answers. So this will satisfy the given conditions. Okay, so if k equal to 6, you can say the given set of equations, they will have infinitely many solutions. Okay, here one more thing, while comparing or taking the part 1 and 2 or 1 and 3, you can decide based upon the complexity. Here if I take 1 and 3, what I thought is the equation will be somewhat complicated when I compare to this 1 and 2. So I have taken 1 and 2 first, then no other go, I have to take either 2 and 3 or 1 and 3, right? It's your convenient.